Hey geometry students, it's Mrs. Fellon. I'm actually going to do a video on lesson 3.4, but before we get into the lesson itself, we're going to go ahead and do a couple constructions. So again, if you don't have, or wherever you're doing all your constructions, or just grab a sheet of paper, you're going to need a pencil and a compass and a straight edge. So if you don't have those things, go grab them now so that you can do the construction with me. All right, welcome back. What we're going to do now is I am going to go ahead and draw. It says construct a perpendicular. We're going to construct a perpendicular line from a point. So what I'm going to do is I'm going to start with a line. And again, it doesn't matter how long this line is, but start from a line. And then also start with a point. We'll label it P. So we're going to construct a perpendicular line from this point. I'm actually going to make my line longer now that I made my point up there kind of high. So this is why I probably should have a ruler here, but that's okay. Okay. So the first thing we want to do when you're constructing a perpendicular line from a point is you put your compass on point P. So put it right there. And then what you want to do is you want to pick, put my finger on here, I want to pick a distance so that I'm going to swing this around so that it crosses this line on both the left and the right. So it doesn't really matter. I don't want it to be too huge because I don't want it to go off my page. So I'm going to pick a distance. What did I pick? 1L, I1, I'm sorry. I'm just going to kind of swing it around. Notice that it hits my line in 2 spots, which is what I want. So I used I1 on mine. Again, it doesn't really matter which one you use as long as it intersects. All right, next step. Do you see how now we have 2 more intersections? Let's call this, I don't know, X, and call this Y. So now what I'd like you to do is put your compass at point X. And then I'm going to use the same one I used before. So like I remember how I put my pencil at 1 or I1. I'm going to do that. And I'm going to make an arc down here. So I'm just going to kind of make like a big arc. It doesn't really matter. I'm going to make mine relatively big just so that I don't have to like redraw it again. So I made kind of like a half arc or a half circle. All right, do the exact same thing, but from point Y. So I'm going to put my compass or put my pencil at I1 and I'm going to do the same thing. All right. Notice that now I have this X. So I'm going to go ahead and take my straight edge and I'm going to connect point P. Oops, mine is not quite long enough. Point P and this. And now that's perpendicular line from a point. All right. I would encourage you to practice that construction a couple different times. And again, you can watch this video over again, but be able to do it on your own. All right, the next one we're going to do is a perpendicular bisector. So what I need you to start with is a line. So go ahead and draw a straight line. All right. What we're going to do is we're going to a perpendicular bisector. So first of all, a perpendicular bisector is for a segment, okay? Because we're going to make a line that's perpendicular and bisects this. So it's kind of a 2-for-1. I'm going to put my compass. I'm going to call this X and I'm going to call this Y. I want to pick a distance on my compass that's more than halfway of my line segment. So I'm actually going to use I1 again because I used it in the last one, so why not use it here? So I'm going to use I1 and I'm going to make a full, you can make a full circle or a full like half circle. So I'm going to make mine kind of big. I'm going to slide my compass over to Y. So put your compass on Y. Do the same thing. So I used I1 again. Let me just get my pencil working. All right, so see how it kind of makes like a fish. And I can extend this on if I wanted to. But what you're really looking for here, this is kind of the telltale sign that you did this correct. These 2 arcs should intersect. And so what you're going to do is you're now going to connect those 2 intersection points. And your result will be both a perpendicular line, so it'll be perpendicular, but it will also bisect, which in other words means that this distance here is the same as that distance there. All right, again, I would practice that construction a few different times. Make sure you can do it on your own. What I'm going to have you guys go to now is page 83 in your student journals. We are going to do, actually going to talk some algebra in this one. So we're going to talk about distance from a point to a line. What I want you to understand is when I ask you to find the distance from a point to a line. So let's say here's a line, here's a point. In order for you to measure the distance, what we're referring to here is the perpendicular distance. In other words, if I dropped a perpendicular line straight down to this line, what's the measure of this segment here? The second definition is a perpendicular bisector. So we just did that construction, right? And so what I know about that is if I make a perpendicular bisector, the line is both, those two lines or segments are perpendicular, but it also cuts it in half. In other words, those two pieces are going to be equal. So we're going to add some theorems to our packet here. So go ahead and grab your theorem postulate thing. We're going to add a few different theorems, 3 of them to be exact. So the next one says, this one is a linear pair perpendicular theorem. So it says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if two lines intersect to form a linear pair of congruent angles. So if I have two sets of lines, so call line L and line M, and they intersect in such a way that these angles are all congruent. So this is congruent to this. First of all, what we have to know is that those have to be 90-degree angles, right? If they're congruent, you know the total adds up to 180. And so then those would have to be 90. And so why that's important is because if we know that they're 90, then we know that those lines are perpendicular. And so then it says, then the lines are perpendicular. So now we know L is perpendicular to M. The next one is perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other line. So that was that one where if we had, like, let's say I had two lines that are parallel, and I have a transversal. If it's perpendicular to this line, then it has to be perpendicular to that line. So that's what it's saying. It can't be perpendicular to one, but not the other. That's what that theorem is stating. The next one said lines perpendicular to a transversal theorem. So again, these are all kind of a little bit crazy here. It says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So this one is kind of stating that if I have a line, and then I have two lines that are both perpendicular to that line, then what we know is this is parallel to that. So I'll say L is parallel to M. All right, this video is gonna be in 2 parts just because I'm gonna go ahead and take a break and gather some stuff for the algebra portion, and then I'll come back. So this will be part 1 of the video, and I'll do part 2 in a second.